Hello and welcome back to my channel. In this lecture, we will be discussing about K-mean clustering and how we can use clustering on data. Clustering is an unsupervised learning technique used to group similar data points together. K-means clustering is a popular algorithm for partitioning data into clusters. It is a simple yet powerful technique suitable for various applications. Introduction to clustering. What is clustering? Unsupervised learning. Clustering algorithms learn patterns in data without labeled example. Grouping of similar data. Data points within a cluster share common characteristics, differentiating them from other clusters. Discovering hidden structures. Clustering reveals underlying structures and relationships within the data. Application in various fields. Clustering has applications in customer segmentation, image analysis, and more. What is k-mean clustering? What is k-mean clustering means? What is k-mean clustering? Initialization, assignment step, update step, repeat step 2 and 3. Now in initialization, randomly select k data points as initial cluster centers. Assignment step, assign each data value points to the closest cluster center based on distance. Update steps, recalculate cluster centers as the mean of all points assigned to that cluster. Repeat step 2 and 3. Iteratively repeat the assignment and update steps until cluster centers stabilizes. Assumption and limitations of k-mean clustering. Assumptions, data is continuous. We assume that data is continuous if we are applying k-mean. Clusters are spherical. Clusters are in spherical shape. Clusters have similar size and we assume that clusters have similar size. Now its limitations. Sensitive to initial cluster center. May struggle with non-spherical clusters. If we encounter an non-spherical cluster, it will be difficult to apply k-mean. Susceptible to outliers. Now, steps in implementing k-mean clustering. What are the steps involved in implementing k-mean clustering? Load and prepare data. Import the dataset and handle any missing values or data transformation. Second, choose the number of clusters. Determine the optional number of clusters using methods like the elbow method or Silhouette analysis. Run k-mean algorithm as a k-mean function in R or Python to execute the algorithm and obtain cluster assignment. Visualize and interpret results. Create visualization to understand the cluster structure and draw meaningful conclusions from the result. As you can see, here are the shape or you can say clusters that are being transferred and performed functions on them. Visualizing clusters in Python, scatterplot, heat maps, and dendrograms. Visualize clusters in two-dimensional spaces. Heat maps show cluster membership using color gradients. Illustrate hierarchical clustering relationship. Evaluating cluster qualities. How we can evaluate quality of a cluster. First, metric, and second column is description. Silhouette score measures how well data points are clustered. Within clusters, sum of square. In this metric, measures the sum of square distance from each point to its cluster center. Now, determining the optimal number of clusters. Elbow method plots WCSS against the number of clusters looking for an elbow point where the decrease is WCSS starts to level off. Silhouette analysis calculates the Silhouette score for different number of clusters, seeking the highest average Silhouette score. Real-world applications of k-mean clustering. Clustering customer segments Segmentations group customers into distinct segments based on their purchasing behavior. Image compression press image compress images by grouping similar pixels together. Anomaly detection identify unusual data points that deviate from the normal cluster pattern. So we are on the final slide, conclusions and key takeaways. K-mean clustering is a valuable tool for discovering patterns and grouping data into meaningful clusters. It has wide range application in various fields. Understanding its assumption and limitations allow for effective use and interpretation of the result. Now, in next lecture, we will be discussing further. Till then, goodbye, take care.